Hello. In this video, we're going to go over problems 16 through 21 from the North Carolina Released Common Exam for Math 2. You can find more information about this common exam and other common exams at the website listed right here. Let's get started. Which function is graphed below? Okay, so we have this curve that's obviously a sine or a cosine if you've seen either one of those. And the options we have are the sine of x, the cosine of x, the tangent of x, or the cotangent of x. Alright, well we just said that it's going to be either the sine or the cosine. So which one of those starts at 0? If you don't remember and you know the unit circle, you can look at your unit circle and right here the sine is your value for y. So if you start at 0 degrees right here, uh, you are 0 off of the axis there. So the sine of 0 is 0. And that's where we start here. The cosine is your x value. So if this circle has a radius of 1, the cosine value there is 1. So it would start up here and then do the curve. So this is going to be the sine of x. If you get a problem like this on your exam is open calculator, feel free to just plug it into y equals and see what it looks like. Now, your calculator isn't going to be, you should put your calculator in degree mode first. So you may not see this curve because it's in degree mode. But you'll still see it starts at 0 and it'll be kind of smaller. You know, it won't look this wide, I guess. All right. You can also just plug in sine of 0 to see what it gives you, and cosine of 0 to see what it gives you. Which transformation will carry the rectangle shown below onto itself? All right. So looking at this, we want it to carry it onto itself, which means in the end we want to look at a picture that looks exactly like this one. You can ignore the line M. We want just the rectangle to be exactly like it is. Alright, so looking at our options here, we have a reflection over line M. If we reflect this rectangle over line M, we expect this point right here to map down to this point down here. But just looking at it, you can tell if you fold this across this line, if this was a crease, it would end up down here somewhere. We could use math to figure out exactly where it would land, but you don't need to if you're doing the test, so I'm not going to do it right now. So folding it over, we know it's not going to be A. B, a reflection of the line y equals 1. Well, right here is the line y equals 1. If you flip the top down, you'll see that it fits perfectly on the bottom. So if this was a crease, that would be the line of symmetry, which means that if we reflected all the rectangle across that line, this part would come down here, this part would go up here, and it would be perfectly exactly like it was. So that's going to be our answer. So reflection over the line y equals 1 for this one. Now just to make sure this it couldn't be the other two, if we rotate this 90 degrees counterclockwise, then that means we would be rotating it like this. Now as you can see, that's definitely not looking the same. We stood it up on the end. Alright, so if we rotate it 270 counterclockwise, well that's 90, 180, 270. Okay, now if we're doing it about the origin, you know, the origin's obviously going to be in a different place, but once again, it's standing upright. It's not even the same orientation as it was. So it's definitely still going to be B. Which statement must be true about the triangle below? All right, looking at this triangle, we notice some things immediately. First off, we have a mid-segment here. These two segments are congruent. These two segments are congruent. This line, QR, is connecting the midpoints, which means this is a mid-segment. And if you remember the mid-segment theorem, then you know that this is going to be half of the side that it's parallel to. If you don't know the mid-segment theorem, then you should see similar triangles. And notice that this triangle is similar to this triangle. Okay, and the ratio of the sides is 1 to 2. All right, so using that information, let's look at our choices down here. So choice A, PQ plus QS is equal to PR plus RT. In other words, this side is congruent to this side. Now that could be true, but it doesn't have to be true. And we're looking for the parts that must be true. So it's not going to be A. All right. Triangle PQR is congruent to triangle PST. Well, PQR is obviously smaller than PST. So that one's not true. It's similar, but it's not congruent. All right, see, ST is equal to 2 times QR. Well, PQ is equal to 2, or PS is equal to 2 times PQ. And so that's the ratio for all of these sides. So QR is, or ST is 2 times QR. All right, so that is the answer. And if you're looking at your mid-segment theorem, that's exactly what it says, that this segment is half of this segment. So if you multiply it by 2, they're equal. All right, just to make sure it's not D, let's look at angle S and angle T. It says angle S and T are congruent. Once again, this could be true, but it doesn't have to be true. S has to be congruent to Q, T has to be congruent to R, but they don't have to be congruent to each other. So the answer is definitely C. 19. The graph of f of x equals x squared will be translated 5 units up and 2 units to the right. Which function describes the graph produced by the translation? All right, so we're wanting 5 units up and 2 units right, and we're using this function right here. Okay, so in function notation, it looks like this. When we go 2 units to the right, we have to do x minus 2. Remember, it goes the opposite direction that you think it would. It's making room to move right. So there's going to be x minus 2 there, and we're going to go 5 units up, so that's going to be plus 5 on the outside to the output to make it go up. All right, so we're going to put this in our function now. So where the x was, we put x minus 2. All right, so that's going to be x minus 2 squared. And on the outside, we put the plus 5. Now all I have to do is simplify this side to see which one it matches up with. Okay, so x minus 2 squared. Now you can't just square the parts inside and say, yay, I'm done. You have to do x minus 2 times x minus 2, because that's what squared means. So here we go. We got x squared there. Minus 2x. Minus 2x. Plus 4. So that's x squared minus 4x plus 4. Plug that in right where you had the x minus 2 squared, because that's what we just did. We simplified or distributed or FOILed or whatever you want to call it, the x minus 2 squared. And so we have x squared minus 4x plus 4 there, and then plus 5 on the end. Our last step is to combine the like terms here. So we've got x squared minus 4x plus 9 as our answer. And that's going to be A. Now to check this one, since it's calculator active, I would plug the original in to Y1. I'd plug the thing I think was the answer in to Y2, and I would make sure that it translated 5 units up and 2 units right from here to here. Number 20. An investment has a balance of $2,000 and earns 3.2% interest each year. If $150 is added at the end of each year by the account holder and no money is withdrawn from the investment, which represents a function that could be used to calculate the investment balance for successive years? All right, so highlighting some key information here. An investment has a balance of $2,000 and earns 3.2% interest each year. If $150 is added at the end of each year by the account holder and no money is withdrawn, what represents a function that can be used to calculate the investment balance for successive years? Sorry, I stuttered there for a second. All right, now you notice there's a lot of yellow up here. So we got to figure out what everything means. Well, the 2,000 is our beginning balance. Now you'll notice your answer choices are all recursive equations. It's the current balance is based on or is equal to something from last year and then something done to it. Okay, so to start with, the initial amount then is B sub 0. This is the stuff we start with. That's going to be $2,000. All right, so this year's balance, if we look at this year versus last year, this year is going to be what we had last year, which is b sub n minus 1, times, we want that 3.2% interest to be added to the 100% of the money that we have right now. So we're not going to just multiply this by 0.032 because that would give us less money than we already have. We're going to multiply it by 1.032 because we want 100% of our money plus 3.2% of our money more. Okay, so when we multiply by that. Now, if we didn't add anything else to this, we would be done. But we're adding $150 at the end of each year. So after we multiply this, we're going to add $150. Alright, so now we got to figure out which one of these answer choices looks exactly like this. Well, it's not A or B because they have 0.032 instead of 1.032. Okay, it's not C because my beginning amount's 150 and we're adding $2,000 each year. And even though that's a better investment because you add $2,000 each year, it's not the one that we have. So it's going to be D. We add 150. Our amount that we're multiplying by is 1.032, and our initial amount is $2,000. So that's it. All right, last problem. What is the approximate length of HJ in the diagram below? Now you may notice that we have some special triangles in this. We have a 30, 60, 90 triangle here, and we have a 30, 60, 90 triangle here. This big triangle right here, I'm not going to use GK in my calculations at all. There may be some kind of calculation that you can use it. I mean, it is obviously some kind of quadrilateral with the right angles here, but we don't know what these two angles are. Just by looking at it, you could figure out this is 30, 60, 90 as well. And this is a triangle. Yeah, I'm just not going to use it. So there may be some way to use it. I'm not though. I'm going to use the special triangles I have right here. Now in a 30, 60, 90 triangle, you know that the side opposite the 30 is half of the hypotenuse. So that means that this side, GI right here, is 200. Okay, and the side opposite 60 is going to be the square root of 3 over 2 times the hypotenuse, so times 200. And when you put that in the calculator and round it to the nearest hundredth, you get 173.21. Now, our final answer is going to be rounded to the nearest whole number, so to make sure that I'm not going to round wrong, I went to 2 significant digits before I rounded. So now I got to do is find IJ right here. So once again, this side is opposite to 60, so to find the hypotenuse, this side right here was the square root of 3 divided by 2 times the hypotenuse. Okay, so that means, I wrote my equation wrong, sorry. That means that 80 is equal to the square root of 3 over 2 times the hypotenuse. Now I gotta solve for h. So I multiply 80 by 2, and I get 160. Okay, then I'm going to divide both sides by the square root of 3. Alright, and so h is equal to 160 divided by the square root of 3. Alright, now, that's not going to help me figure out the side HJ though. I need to figure out IJ here. Well, IJ is the side opposite 30, so it's going to be half of 160 divided by the square root of 3. Alright, so if you divide this by 2, you get 80 over the square root of 3, which, once again, if you calculate that to the nearest hundredth, you get 46.19. When you add these two things together, you get 219.3, no, 219.4, which is C. Now, there are other ways to do this one. If you don't remember your 30, 60, 90 triangle, never fear, this is right triangles anyway. You can use trig, use sine, cosine, and tangent. You could use the cosine here to find this side, the tangent to find this side, and On this one, once again, you could use tangent as well, and then you're perfectly fine doing that. So once again, you don't have to do all these problems the exact same way I'm doing them. There's lots of different ways to do multiple uh, ones of these problems. Sometimes there's only one way to do it. Well, I don't even know if that's true. Uh, most of the time, I can't prove it, can't write a proof for this, but most of the time there's more than one way to do a problem. Uh, so if you have another way to do it, feel free. And as always, if you have any questions about any of these problems, feel free to comment on this video. All right, well, have a good one.